Welcome to episode 1 of Beyond the Button. This series, we're going to take a look at more forensic-based concepts. We're going to take a step beyond the tool. We're going to take a look under the hood of some of these artifacts to see how they work and how that can help you in your investigations when recovering, say, deleted or maybe corrupt files or things that your tool just can't read due to the nature of the data. So for the first episode here, we're going to take a look at VARINTs. So first, before we talk about what they are, we're going to talk about where you can find them. And primarily in forensics, you're going to be looking at SQLite databases, and SQLite databases have a heavy use of VARINTs in their addressing scheme for the rows and columns within the database. So as a quick review, a SQLite database stores information across one to many tables, and the information is organized by rows and columns. So each row is actually referred to as a cell when it's stored within the file itself, and then you still have your columns. And these are also counted, identified, and pointed to within the table itself. And so we'll look at the VARINTs that give us some of the information relative to the row and the column and how we can read that from the hexadecimal side. So how do our forensic tools and you as a user, as an analyst, determine how these tables are built and organized? Well, that information is stored within VARINTs. So now, what is a VARINT? A VARINT is an efficient method for storing integer values, so numbers without decimals, using the least amount of space possible. And if you know much about SQLite, you know that it likes to be efficient with its data. It doesn't like to use any extra space that it doesn't want. So we're going to take a look at a very oversimplified image to illustrate just how VARINTs work. So in this file here, this is our mock database, we're not using VARINTs or this method of storing integer values. And what we've done is we've reserved 4 spots. No matter how much data we're storing, we've reserved 4 spots to address that data. So we have four blocks here to describe 1. We have the next 4 to describe 3, the next 4 to 2, next 4 to 4, so on and so forth. And we filled up our file. Okay, we filled up our space. And so this is where we've reserved a set amount of space. Now, a lot of files, including SQLite in some places, will use this method where they'll allocate a certain byte length to store this attribute. Whether or not the attribute needs that much all the time, it's going to be a block size, and sometimes it's 0 filled, whatever. Now, if we were to, again, oversimplifying here to show the concept, if we were to use a VARINT to where it flexes, and in this case, we're going to match the size that we're going to write 1 to 1, 3 to 3, etc. in this, only using the requisite amount, we save 2 rows and we can store more data. And this is what using a VARINT accomplishes, and SQLite uses that a lot. The issue with that is that the database needs to know how to read VARINTs. And if you are reading the data out of the hex or something due to a corrupt file, or you're recovering a partial out of deleted or something, you also need to know how to read a VARINT to address your data, to rebuild it. On the right, we have a hex view of an SMS MMS out of SMSDB and iOS device. First off, one attribute that we can take a look at is the size of the cell. Remember, the cell is the row, okay? And this is going to give us the number of bytes for the allocated record, okay? Not including the cell header. So we have this hexadecimal 85, and we're also going to include the next one, 1B. And we'll talk about how we know that here in a second, okay? So 2 bytes. Then the other place a VARINT is used is the row ID. The row ID uniquely identifies every row within the table. And so we've got 2 of those. FTK will actually tell you this numeric value, this row ID, within the table. You can see it right here. This leftmost all lower row ID is actually being read from the hex. This is not part of the table itself. Like, you couldn't write a SQLite query to pull this row ID column. This is the first row of the table. This is parsing out the row ID out of the hex and bringing it in here. So we have that there. And then lastly, the one we're going to talk about is the record header size. So what this indicates to you as a user is the size of the record header. And from the record header, you're going to determine the columns within your table. Now, we're not going to take a deep dive into that. We'll save that for a proper training. These are a little bit of a spoiler on the outcome, but we'll show how we determine these values in the next few slides. How do we calculate a variant? All right, so we're going to talk first about the size of our cell. And again, a little bit of a spoiler here. We know that the variant for our size is going to be 2 bytes. It may or may not be 2 bytes. It could be larger, it could be smaller. So the first thing we're going to do actually is just look at the first byte. So in this case, hexadecimal 85. We have the first byte. We're going to write here in this little table, and we're going to determine how many bytes we need to look at to determine what the size is. So we're going to break this into binary. 85 translates into 100000101. That is binary for hexadecimal 85. And we're going to take a look at the most significant bit. The most significant bit is the leftmost bit, or in this case, 1. If it's a 1, we know that we need to continue and also include the next byte. So now we take a look at the next byte. If we were to scan back up here, we can see 85 in hex followed by 1B. That's the next byte. And we know we need to look at 1B because 85 starts with a binary 1. So we take a look at hexadecimal 1B. We convert that to binary. It starts with a 0 in the most significant bit location. So that means we stop. We have all the bytes that we need to calculate the size of the cell. If, for example, this was something else where 1 was in the most significant bit, you would take the third byte, and so on until you came to 1 with a 0. The maximum number of bytes in a SQLite database for a variant is 12. So we stop. We have our 2 bytes, hexadecimal 851B. And that's why I said it was kind of a spoiler. You wouldn't actually know that without doing a calculation even in your head. The next step is we actually drop the most significant bit, okay? And then we're going to combine them. We can drop any leading zeros. They don't add anything to our value. And we combine those up into one long binary string. And then we can convert that. So we now know that the size of the cell is 667 bytes. These bits here, the leading bits, are only used to instruct the program, etc., on what bytes to use. You do not keep them in the calculation of your variant value at the end. All right, so we've determined the size of the cell, excluding the header, and we go to the next one. The next one for the row ID functions exactly the same. So pause the video if you want to try it on your own. Pretty straightforward. Give it a go to calculate what the row ID is for this specific cell. So let's just fill that in. We get hexadecimal 81. When we convert that to binary, we get a 1 in the most significant bit. So we know that we also need hexadecimal 2F. Hexadecimal 2F starts with a 0, so we know that we do not need a third. We drop these most significant bits and combine. You can drop all these zeros. They wouldn't add anything to it anyway. Combine, and we get 175. So the row ID for this cell is 175. When determining the number of bytes that you need, there's a simple trick you can use to determine where you need to stop, and then you can gather them all up and convert it in whatever way you want. So if we take a look with this little cheat table here, so what we want to do is look for the leftmost nibble or the most significant nibble. And so we'll put it in here. So if this was our hexadecimal value, 85, we're going to look at just the 8, and you can convert that into binary, and that's going to be 1000. Anything above 8, 9, A, B, C, D, E, F, they will all have a 1 in the most significant bit area, in the 8 bit, okay? So anything 8 and above will require the second byte. So we go to the next byte. Now, if you had something like hexadecimal 075 Anything 7 and below will always have a 0 in the 8-bit location. And that's because if we had 1 here, 8 times 1 is 8, and that would already make it larger than 7. So it's always going to be a 0 here, which means we will stop. So if it's 7, 6, 5, 4, 3, 2, or 1, you know that you're at the end. Which, if we take a look at our record header size, this is a variant. Just looking at this, it starts with a 4, so we have a 0 in the 8-bit column, 1, 0, 0, 4, 4, okay? So we just have that. And the nice thing about single bit variants is you can just convert hexadecimal 43 into decimal if you need to, and it's good because it's a 0 and that's just the way it is. So you could just convert that straight out into decimal and get your value. So why do you need to know this? Well, the cool thing about SQLite databases, they're very structured from the top of the database all the way down. But you can't automatically carve, say, a deleted database or a corrupted database if you've lost the initial header or if it's fragmented or something. So if you get a search result into a random page or it's been partially deleted or overwritten, you could still pull those out and still bring everything out into its column. I hope you enjoyed this video on jumping beyond the button, looking at some hexadecimal, how files function, and the ways that you can solve some problems. If you are interested in SQLite, I'm actually going to be doing a presentation on May 26th over at CyberHub. I'll have a link in the description. You can come check it out. We're going to be talking about behavioral analysis using SQLite queries to determine user behavior and how that can help paint a picture in your reporting and have your evidence tell a story. Come check it out. Also over on our training website, training.accessdata.com, we have added a class free for all of our pass holders, a 3-day SQLite query writing course. Come check it out. We'll spend 3 days learning from the basics all the way up into advanced SQLite query stuff. It'll give you a good introduction, a good foundation to jump out and do it on your own. So if you're a pass holder, register for that. It should show up on your pass now. If you're not a pass holder, you can either buy a pass and get a lot of classes, including SQLite, or you can purchase straight into SQLite as well, if that's something you're interested in. Thanks for watching. We'll see you again next time.